So I have 4 to the x plus 2 equals 3 to the 2 minus x. So on your quiz and the homework, you've been solving these where you can make the bases match, right? Okay, can I make the 3 and the 4 match? Yeah, there's nothing nice that's going to make those match. So we have to try something different. We can actually take the log of both sides. You can use log as an operator or natural log. It doesn't matter. I'm going to do natural log because it's only 2 letters instead of 3, so it really doesn't matter. If there's an E in a problem, you definitely want to use natural log so that the base makes sense. You could have picked log base 3 or log base 4, but you certainly don't have to. So if I start with this and I do the natural log of both sides, where do those exponents go now? In front, okay? So x plus 2 times natural log of 4 and 2 minus x times natural log of 3. That's good. We've gotten our variable out of the exponent because it's very hard to solve when the variable's in the exponent. All right, so now I'm just going to distribute. So I'm going to have x times natural log of 4 plus 2 times natural log of 4 equals 2 times natural log of 3 minus x times natural log of 3. Okay, just distributing. All right, we're solving for x, right? I have a couple of x's, so what do you think I need to do? Yeah, get them all on one side. So I'm going to leave the x natural log of 4 over here. Bring over, so plus the x natural log of 3. And then on the other side, I'll have my 2 natural log of 3 minus 2 natural log of 4. All right, what do you want to do on the left now? So you could condense, but if you're going to condense, you'd have to put the x back in the exponent, and I don't really want to do that. So what else can we do? It's not wrong, it's just going to take you on a very long path, and you're going to end up here again. Yeah, there we go. I can't factor out natural log because it's not a term. It's an operator, so that'd be like, I'm going to factor out the multiplication. Okay, we can't do that. We can factor something. What can I factor out? Yes. And that helps us because that's what I'm trying to solve for. So factor that out. And then how do I get x by itself? Divide, yeah. So I'm left with 2 natural log of 3 minus 2 natural log of 4 over natural log of 4 plus natural log of 3. Okay, that is an absolutely acceptable answer. There are other ways I could write this, okay? I could use what I know about my log properties. I could say this is really the natural log of 3 squared minus the natural log of 4 squared. And my denominator is really the natural log of 12. Or my numerator could be the natural log of 9 over 16. And then divided by the natural log of 12. Just recognize that all of those mean the exact same thing. Okay? Again, if it's a multiple choice question, you have to be able to recognize all of those as correct answers. Okay? All right, we'll pause there because I know lunch is coming in just a minute. All right, so that comes back as a second example. That's right, guys, do you see how this is a little different than the last one? Okay, it's not an exponential equation to start with. It's got a bunch of logs going on. Any thoughts as to what we should try to do?
Condense the left side.
Yes, condense the left side. So this then becomes log of x times x minus 3 equals log 28. All right, do you see how I have it down to a single log on both sides? So what could we do from there? Yeah, so I'll go ahead and multiply and set them equal. So x squared minus 3x equals 28. And at this point, we're just solving a quadratic. So x squared minus 3x minus 28 equals 0. We can factor x minus 7. X plus 4. We get two answers, x equals 7 and x equals negative 4. Do they both work? No. Which one's out? Okay.
Do you have to worry about them being extraneous if they're positive?
No, it all depends on what the original equation is. So just think, what if this had been log of negative x? Then you'd want the negative one, you wouldn't want the positive one. So I always just go back to the original and check. Yeah.
So if you get two answers, would you just have two asymptotes?
They're not, these aren't asymptotes, they're the solutions that make this equation true. So it's possible that you could have more than one that actually works. Because really what you're looking at, I mean, when you're here, I'm asking you, when do these two log equations intersect, is really what we're looking at. So depending on anything weird that's going on with the shape of this, they could intersect more than once, but most of the time it's just once. Okay. All right, any other questions on 2? Let's try 3. Slightly different once again. With it being e to the 2x, e to the x, negative 12, I see this as u squared plus u minus 12. If I had just given you that, would that be easy to solve? Yes. What I've done, I've just done a simple substitution. I'm saying let u equal e to the x. Some of you will see this and won't need to do the substitution, like you'll just understand the factoring, and that's great. We're practicing using u as our substitution because in calculus you're going to do that a lot. You'll hear u substitution over and over. So I'm just going to do it on this problem. So then look at my u equation. I can factor that, right? U plus 4, u plus 3. So I get u equals negative 4 and u equals 3. Am I solving for u? No. What am I solving for? Okay, so x is the variable I need to find. So I need to rewrite this now as e to the x equals negative 4 and e to the x equals 3. All right. Couple things to think about here. We have to solve both of these. The way you can do that is by taking the natural log of both sides, or just turning it into a natural log equation. So if I do that on this first one, I take the natural log of both sides. So you guys see a problem.
And take the natural log of negative 4.
I cannot take the natural log of negative 4. And you may have recognized that even before we did the natural log. Think about e to the x. That's just an exponential equation, right? The number raised to an exponent. The graph, remember, has that horizontal asymptote and it grows exponentially. Is it ever going to equal -4? No, it doesn't go below the x-axis. So right away you should realize, okay, this one does not work. But then the other side, take the natural log of both. That exponent goes in front. And what is natural log of e? 1. Okay, that's got to be quick. You got to know natural log of e is 1. So I just know that x is equal to the natural log of 3. Questions? Do whiteboard practice now. So that's the end of notes. So let's go ahead and do some whiteboards. Yeah. Yeah, go ahead. Yeah.
Right here.
Okay. All right, guys, let's try one. 2 to the x minus 1 over 2 to the 3 minus 4x equals 16. I think you got it. I don't know what happened.
Done.
Oh, go ahead and throw it in the trash can up there, and then there's something back there. Yes. 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 No. Close. No. 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 Yes. No.
No. Ah, no. It's just a fraction. Yes, like it's a number, and that's. Yes. No. You do not need to use any logs or natural logs or anything in this one. You can make the bases match. Are you stuck, Chris?
Okay, I think on this side, these are the same base. What if I give you?
Oh my god.
And then you said exponents equal. So it's really this minus this.
Makes so much more sense.
You would add.
Wait, what did you get? Was it
All right, guys, let's go through it now. No. All right, let's look.
Is it this?
No.
It's gotta be.
Yay! All right. If I gave you like this, yes. If I gave you that, what would you do with the exponents?
I'm so
subtract?
Because they have the same base, right? So we can subtract exponents. Don't these have the same base? So can I just subtract my exponents? Yeah. Sure. So this is really 2 to the what? Negative 5x minus 4. And then this side is 2 to the 4th. There's other ways to go about this, but this is one way. Does that make sense what I've done?
Yes.
Okay. Bases are the same. Yeah. It's just using your exponent rules. Yes.
So then wouldn't it be positive
Plus
5x?
3.
Yes, thank you.
This is 3. Oh no, you're right. Sorry, I was
And then you're done. Okay. Some of you made that a lot trickier than it is. I like the creativity.
It's simple.
All right, let's try again.
You get points for C would equal 4 and then negative 4 is 0.
Okay, let's try another one. I'm confident some of you will get very creative on this one. I would do a U substitution on this. Okay, yeah. So that's what u equals. What do I want you to solve for? Oh.
No.
You let u equal 3.
Okay. Okay. Yes, you can do that. Yes. Good work. There should be 2 answers on this one. This negative. Right. And then you actually need to solve for x. Yes. Yes. One of them. Yeah. That's the other one. So one of those you can simplify more. Yes. Good. You can write them in different ways, but that's one way to write it.
Why are you telling me now?
Well, he wrote it differently.
I read
Do you recognize they're the same though? Like if
Yeah.
you did change a base on his, you'd get yours. I think yes. That's okay. Yes. 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 Yes.
Whoa,
Yes. All right, let's look at it. So I would let u equal 3 to the x. You've got u squared minus 8u plus 8. We're all okay with this. Then we have to actually solve. So guys, the right side here, some of you like took the time to rewrite this as logs. Like, just use your brain. You know what x has to be, right? 1? Okay. Don't overthink them. Okay, this one though, you can either rewrite as a log, you can take the natural log of both sides. I don't care how you get there. It is natural log of 5 over natural log of 3, or log base 3 of 5. Do you guys see the change of base happening there? No, is that just me that sees that? Yes, that's there. Okay. All right, let's try another one. Question on that one? Anything? I heard this. So log base 3 of n squared minus 5 to the 4th equals 4.
Yes.
It's like fun, right? Yep. Yes. That's yes. Close
Oh, wait.
and simplify.
Oh.
But yes, you should have added that. Yes. With yes.
Okay.
You got that. Forgot one thing. Simplify it, but yes. Yeah. I won't make you rationalize, but I do make you simplify. Yes. 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 Is there plus or minus in front? Yes. Okay. Yes. 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 Simplify. Oh, I see it on the left. Sorry. Plus or minus. Right? Okay. Yes. 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 Simplify it.
I'm saying.
Yes. All right, guys. Let's go through it just because I think there were a lot of different ways that you guys got here. Some of you, did you actually do 3 to the 4th and think about that? Okay. That's fine. I think this is an easier way. Bring the 4 out in front.
25.
Can I divide both sides by 4? So then it's 3 equals n squared minus 5. It's fine if you figured out 81 and then took the 4th root of everything. Like, that's all okay. You can still get there. But think about those exponent rules to help simplify things for you, okay? Let's do one more.
The Backstreet Boys. The Backstreet Boys.
If you set log base e, just say L in a base. That's natural log. Don't ever write log base e. Okay. Yes. 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 Yes.
Shortly.
All right, guys, let's flex because we're almost out of time. I would take the natural log of both sides. So then it's x plus 1 times natural log of e. But guys, what's natural log of e? So this is really just that. Natural log of 8 minus 1. Okay? All right. Homework is in your packets, 2.7. And you guys can do all of it.
Can, but should.